Okay, can you hear me?
Yes, teacher.
Can you see the geometer sketchpad screen?
Yeah, can.
Okay. Now, I need to go through this with you or not, Lisa? Go through, Okay, right. Uh, the question is like this. 4 over 5 square root of x plus 2 square root of x. Now, this function, you have to change to index form, right? So change to index form. Uh, After doing so many questions, you can straight away change to index form. So you look at this, square root of x means x about half. When the square root is at the bottom, it is negative half. So when it's always at the denominator, you just add the negative there. Okay, right. So when you differentiate 4 over 5 x to the power half plus 2 x to the power of negative half. So you bring down the first term, you bring down the half. Bring down the half, then the index you minus 1. So this also you bring down the negative half, the index you minus 1. Now this process I show you here, the index minus 1 is at the beginning. Now later on, I'm not going to show you there is a minus 1 there. So you have to imagine. I told you you have to imagine that in minus 1. So next time I'm not going to show. So I will skip straight away from here. Then I will skip to something like this. From half, I do inside my mind, then become negative half. Negative half minus 1 becomes negative 3 over 2. Now this function has already been differentiated. So already differentiated. Oh, I have not recorded yet. Did I record? Alamak.
Yes, record already.
Recording, okay.
Yeah.
Then where am I? Okay, here. From here, you see the after differentiating, you have to put dy dx. Right? So next time from here, half straight away we jump to negative half. Negative half straight away we jump to negative 302. So I'm not going to show you these things. Minus 1 there. Why? Because by right you should know how to do it mentally. Right? Then another thing is in the working here, maybe I will still show you minus 1 because some students they are a bit they cannot imagine, so I still show the negative 1. But if you have really gone through the exercises, no need to show, you know what I'm doing, right? So it's for those that didn't go through the exercise. But if you didn't go through the exercise, next time it's going to be more and more difficult because as the differentiation get more and more difficult, you have to differentiate a few times. Then I I am afraid that you might not be able to follow. So you have to try this question, the basic questions. Okay, coming back to this, the number they can cancel away become 2 over 5. Cancel become negative 1. Now, many times they ask me whether you can leave the answer like this or not. If they put there, simplify your answer, you cannot leave it in this form. You have to make sure that the negative goes to the bottom and the fraction becomes a square root or cube root or things like that, right? But normally they will ask you until square root lah. The most is cube root. They won't go and ask you fourth root, fifth root like that, no. Right? Then the number 3 over 2 here, 3 is the this one, x to the power 3. And the number at the denominator, the half here is square root, right? So you don't terbalik, mix up the two. Okay, right. Finally, this is the form that we want. This is the form. This is usually the format that we accept, right? So if you are weak in indices, um, it doesn't matter actually. If you try a few times, the important is in try. You try a few times. This thing is nothing to you really. You can become very good at it. You can imagine what is going on, right? It's not a problem.
Teacher,
Yes,
for we now learning for the differentiation method. Is it
yes.
same with the first principle method? It's just to find the gradient, is it?
Yes, we just find the dy dx. Dy dx is the gradient of tangent. But other than gradient of tangent, if you change the y and x to become other physical quantities that you have learned in physics, then it is not the gradient anymore. It becomes the rate of change, or it's a comparison between the change in a variable with the change in another variable. Right. I don't know whether the school you have covered all the application of differentiation or not. Rate of change, maximum, minimum, then maximum, minimum, rate of change, then delta y, delta x, the small change. Have you covered this in the school already or not? Teacher teach already or not? Li Ying, got or not? Teacher teach.
Teacher,
Where is the teacher teaching now?
teachers starting chapter 3, but she never come to school 1 week.
Oh, okay. So chapter 3, starting chapter 3 lah. That means you have covered chapter 2 already. So you should know that dy dx, it means the change in x compare with the change in the change in y compare with the change in x, right? Now what we are doing here, if you call it x and y and so on, you want to think of it as gradient of tangent is correct, right? Because if you think of it graphically, in terms of graph, then dy dx is the gradient of tangent. But let's say if it is not y and x, is volume and radius, then is the rate of change of volume to the change in the radius. It's a comparison between the change in volume with the change in radius, right? But you don't have to worry about all those things. When we come to it, then I will let you know, right? So one more thing. Yes. Now, finding dy dx here is the same as finding dy dx using the first principle, correct? They are the same thing. We are finding the same thing, except that using the first principle method is more difficult. This method is easier, and we can differentiate more complicated functions with square root and so on. The other one, when it comes to square root, first principle, I think with your knowledge of mathematics, you cannot do. When it comes to square root, you need more advanced knowledge in mathematics. Okay, right. So this one, I have shown you. We go to the next one. Now the next one is this, right? Question number 3 that you asked. So I'm going through with you. It will only be helpful for those who have done their homework, right? If you have not done, you look at these things that I'm doing now, oh, it is very complicated to you, right? So if you have done your homework, I go through with you, then it will be easy. Whatever the mistake that you make, when you see me explaining, then you have corrected your mistakes already, and you try again, everything will be perfect, right? Now, if for those of you haven't tried, you can try, right? After this, you're going to try again. Right, we have to differentiate this. You can see the bracket there. Now, with the bracket there, you cannot differentiate one by one like you have done here, Li Ying. You have to remove the bracket. Now, if you don't remove the bracket, can differentiate or not? Can, unless you have learned these things, this one, the chain rule, product rule, quotient rule. This will enable you to differentiate without removing the bracket. But other than that, at this stage, you have not learned all the rules yet. So what you can do is you remove the bracket, or remove the fractions, the line, then only you can differentiate at this moment, now. Okay, so I have to remove the bracket. Remove the bracket means you multiply inside. So when you multiply inside, 20x squared. When you multiply inside, try to do mentally. 2 plus half. 2 plus half is 502. Number and number, x and x. The 4 here and the negative 1, negative 4. X squared and half is 2.5, right? 502. So you should arrive at this stage, right? Arrive at this. You cannot, then you have to practice. Practice, then make mistake, you show me. Then I tell you what is your mistake. Sometimes I may be sleeping, like just now I was sleeping. I usually take the afternoon nap. So if I'm sleeping, then I cannot answer you. If I'm not sleeping, then I will answer you, right? If you see long time and no response, maybe I'm sleeping, right? Okay, right. This is the final one. When you multiply inside, 20x squared. Multiply inside, there's no number, so it will be 4. 4, 502. Now, in this form, you have not differentiated. So this thing is still called y. So when you differentiate, okay, bring down the 2 becomes 40. 2 less by 1 become x. Right? For those of you have do a lot, then you can skip from here. You just skip to this step. Or you can get penalized if you skip from here to here or not. No, right? No, because it's understood. It is very simple, right? Because if every question you show the working like this, it will take up a lot of your time, right? For me, like just now, Li Yin asked, why my answer is different? Because I try to show step by step. When I type, then I forget everything. Normally, when I do, I will skip straight away. I write down the answer. That's why you want me to show properly. Then sometimes I can make mistake. Okay, never mind about that. So you try to jump from here to here. No, so negative 4, right? Negative 4, you put down negative 4. Then this number, 5/2, right? Then this one is less by 1. 5/2 become 3/2. So now you multiply out all the numbers, number with number, 40. X with x, there's only one x there, so it's x. So you multiply all the numbers together, 20, 10, 20 divided by 2 is 10, so write down 10. This number, x to the power of 3/2 is, the 2 at the bottom is square root, the 3 at the top you put down cube. Okay, right. Okay, another type of question, this one, right? Again, we see the bracket here. Now, with the bracket there, you cannot differentiate. You have to expand. How you expand? You use this one. Use this one, right? You use this one, right? Ax squared plus 2ab plus b squared. So you use this one to expand the two terms inside the bracket. Okay. Now, you cannot differentiate with the bracket unless you use the rule. So now you have not learned the rules, you have to expand. So when you expand, normally I will expand in one step. X square become x to the power 4. 2ab, 2 times x square times 4 over x, like that. 2 times x square times 4x. If possible, you do mentally. So this multiply with this is 8 This multiply become the x square, and the x can cancel and become x. Then 4 over x whole thing square, 16 over x square. Now in this form, you cannot differentiate lah, because the index is at the bottom there, the denominator. So you bring the index to the top, become 16 x to the power -2. Now you can differentiate this x to the power 4, bring down the 4, become 4. The index less by 1 become 3, so 4x to the power 3. Differentiate 8x, become 8. Now this one you have to multiply with -2, because you bring down the -2. So -2 multiply with 16 becomes -32. So we have -32 here. Then the index -half minus 1 some more, then it becomes -3. So this will be the answer already, right? This will be the answer, but if you want to write down properly, write in this form. With the negative index, you bring it to the bottom. Okay, the next one. Okay, next one will be this one. Next one will be this one here. This one here. Okay. I move this over. Right. Next one will be this. Now, again, you see in question C, you have bracket and also at the same time that line at the center there. So this means that you have to expand the bracket, then divide one by one, one by one, one by one, like that. Because this is the only method of differentiation that you have learned. You can only differentiate term by term. Or with the bracket there, you don't know how to differentiate yet. Maybe on the second half of this lesson, I will show you how to differentiate with the bracket first, right? The others, the product rule, quotient rule, we use another lesson, right? So I give you some time, I go slowly. I give you some time so that you can do the homework, you can catch up, right? You can catch up. This is even better than the tuition class that you are going to attend, because the tuition class you attend, after tuition class you cannot ask anymore. But here, after the class, you just do whenever you want. You just post it on the Telegram. I will answer your question, right? If I don't answer, means two things: either I'm sleeping or I go out, right? So two things, right? So, but you don't worry, when I'm back, I will turn on the WhatsApp, because your group I already pinned to the top. So whenever I open my Telegram, I will see your message first, right? So I'll answer your message first. Right. Coming back to this one, coming back to this, right? How to do? So you have to make it into one term, one term, one term. So how to make it into one term, one term? Expand the bracket first. So you expand the bracket, you have to expand in one step, right? So if you have not, you just try, right? You just try. After a few times you can do it already, right? After a few times. Now some girls, not maybe not you all, but some girls, they didn't do the homework in form 3, form 2, right? So mm, they cannot expand in one step, right? But you just try a few times, you can expand in one step, right? So when you expand these two bracket, you will get this function, negative 4x squared plus 5x minus 1, right? Now how I get it? Now I see here, this is 4x, this is negative x. 4x multiply with negative x, negative 4x squared. Then how to get the term involving x? I will gather here. 4 times 1, negative 1 times negative x. So 4 times 1 is 4x. Negative 1 times negative x is x. So 4x and x become 5x. Okay, this one I do mentally. All right, then how to get negative 1? Number times number, you get the number here. Negative 1 times 1, negative 1. Now this x, square root x, you have to change to index form, become x to the power of half, like that, x to the power of half. Then so this one not ready yet, right? Because what we want is one term, one term, one term, like that. Then you differentiate one by one. So in order to create that one term, one term, one term, so I use 4x squared divided by x to the power half. Now divide means you subtract the indices. So again here 5x divided by x to the power half, negative 1 divided by x to the power half. So I see the x there, I subtract. 2 minus half, 3/2. Now this one no number. No number means x to the power of 1. This one, 5x to the power of 1. 1 minus half become half. Now this one at the top nothing. So you just bring the half to the top. It becomes negative half. Now some, because it takes a very long time. So some girls think, oh, I get to this step already. Then they forgotten that they have not differentiated yet. So they just leave this as answer, then they go and do answer another question. This type of carelessness you can overcome. You do many times, then you can overcome. And I'm sure before the exam, you will do very well, right? So now I'm going to differentiate one by one. Okay, 3/2 bring to the front. 3/2 minus 1 is half. Can do mentally or not. I said I'm not going to show you the minus 1 on the screen. You have to imagine, right? Okay, so 3/2 minus 1 become half. Okay, then this number 5 I copy down. Those numbers you don't differentiate because a x to the power of n become a n x to the power n minus 1. So the a in front, the number in front here, the 5, or is known as the a, you don't differentiate, you just copy down like this, copy down here, right? Copy down here. Then the half you bring down to the front here. The half you bring down to the front. Then the half here, you have to minus 1. Half minus 1 becomes negative half. Negative half. Okay. So you have something like that. Just leave it first. We go on to the next term. Oh, this one, you have to bring down negative half. So negative half with the negative in front become positive half. So the negative half multiply with the 1, negative 1 here, become positive half. Okay, so this one, that's why I get positive. That's why I get positive half. Then the index negative half minus 1. So you put inside your mind there, negative half minus 1, negative 3/2. So that's how you get negative 3/2. So now the next step is you multiply all the numbers together. Now what you have done here is differentiation. So you cannot put y in front anymore. You have to put dy dx here. So you put dy dx here, right? Then the numbers you simplify. This one multiply this, it becomes negative 6. X to the power half is square root. Then 5 times 2, 5 times half. So it's 5/2. This negative half you can bring to the bottom. Okay, so please note that the 2 is at the bottom, the 5 is at the top, because this x has a negative index, so the x has to go down. Then the last term 1/2, 1 is at the top, 2 is at the bottom, so 1 at the top, 2 at the bottom. Now negative 3/2, you bring down, negative you have to bring down, so it's x to the power 3/2, right? And The square root, the half you convert to square root. The half here also you convert to square root. The cube you remain as cube here. So this is the differentiation, right? Any questions so far?
Understand, teacher.
Huh? Can
Understand. Right.
understand. Okay, right. So understand, then no more problem to show you, because these are the things that you asked me. Oh yeah, one more here. This one, this one, right? Part C, right? Part C, you have y, then x square plus 4 over x square. Now, as I've said earlier, you only know how to differentiate one term by one term. So the x square is shared by these two, x square and 4. So when you split them up one term by one term, every term you have to divide by x square. So x square you have to divide by x square. 4 you also need to divide by x square. So as a result, you get this thing here. X square over x square, 4 over x square. Now, x square over x square is 1. When you cancel away, become 1. Now this 4 is at the top, so you put 4. If the 4 is at the bottom, then you put 1 over 4, right? Then here x square is at the bottom, you move to the top, become x to the power of negative 2. Now, what you have been doing is just simplification. You have not differentiated the function yet, so it is still y. You see, every time I emphasize to you when it is y, when it is dy dx, because when I mark the students exercise book, I see they simply put the y and dy dx there. So now I remember, I tell you, don't mix up the y and dy dx. Although you may know how to differentiate, if you mix up, they will still mark you wrong. Probably they cut your marks or what, right? Something like that. Right. So here, after you have simplified, become 1, differentiate 1, becomes 0. Differentiate this, become negative 8. The negative 2 bring in front, multiply by 4, become negative 8. Negative 2 less by 1, become negative 3. So this one, throw away really, 0 throw away. Now this negative 8 is at the top, so you write down top. Negative 3 is at the bottom, x to the power negative 3 is at the bottom. Okay, right. Okay, right. So now you know how to do this basic differentiation. Now I'm going to do something more advanced one, more advanced, right? So the more advanced one is this. Okay, more advanced is this. The first, you see, the simple one will be like this. The simple one will be like this. How? Where is it? Simple one will be differentiate x, you get the number. Differentiate number, you get 0. Right? These two things you must remember. Then another thing is number 3. You have to remember, if you see bracket, you open up the bracket. Number 4, if you see the straight line like this, you split them up into one by one. Now these 4 things, they are the basic, right? Very basic. Right? You have to split them up. Split them up means you divide. Now, these are the basic things. Now when you come after the basic, you have 3 rules. The 3 rules, they are the chain rule, product rule, and quotient rule. Now, in order to understand this thing, dy dx equal to dy du dx. Now, you cannot imagine a composite function. Composite function, as you have learned in Form 2, is actually one function you substitute into another function. So this u is another function. x is one function and you substitute into another function u. So if you cannot imagine this formula, you can throw away this formula and you listen to what I say. Right? I use my mouth, come up with words, and these words you just follow lah. You just follow the words that I say. Maybe other people don't understand. This type of word is between you and me. Between you and me. You just follow what I say. Then you should be able to do all these things. Okay? So you don't worry if you don't know this formula here. This formula. Okay? Right. Okay. Now, I'm going to do the first one. Today, I'm going to do first one. Now, if I do the second one, then if you have not done the basic questions yet, and you're going to be very advanced, you sesat already. So I try to do this one first, right? Try to do this one first. Then I let you try the basic differentiation again, right? The basic differentiation again. So what makes this chain rule different from product rule and different from quotient rule? When am I going to use the chain rule? When I'm going to use the product rule, and when I'm going to use the quotient rule? So I only used my own words to tell you lah. It is not, how to say, it's not the official term. Other people may not understand, right? So I'm going to tell you. Now, if you want to use the chain rule, you see a bracket. Bracket then raised to a certain power. You use the chain rule. Uh, Chain rule is used for differentiating composite function. And this, in fact, if you see a bracket then raised to a certain power, then it is actually a composite function. Right? So you don't have to worry about the rules here. Okay, one more time. How do you recognize that you have to use the composite function? There will be a bracket, and the bracket is raised to a certain power. Usually it is more than 2, because if it is power of 2, you can always do like that, expand. You can always expand, multiply out, and you differentiate one by one, like this, right? Like this. You can always expand. If it is power of 2, something to the power of 2, you can always expand like this one by one, then you differentiate one by one. However, when you need to use the quotient, the composite function, if you use the chain rule, the power here is more than 2, usually lah, more than 2, so that you cannot expand them, right? But of course you can expand if you know binomial theorem. Binomial theorem we have not studied, never mind. So how to recognize whether you want to use the chain rule or not? For composite function, you see a bracket then raised to a certain power. Oh, this is chain rule. How to differentiate using the chain rule? You listen to me, You differentiate this power first. The 3 you just copy down. The 4 you bring to the front. Then the 4 becomes less by 1. Okay, that's the first step. Second step, you differentiate what is inside the bracket. What is inside the bracket? Then you get this, the 2 here. Differentiate 2x become 2. Differentiate 1 is 0, so you don't care. So what are the 2 steps? First step, you differentiate the bracket. What I mean by differentiate the bracket, that means the index of the bracket you bring down, then this one less by 1. Okay, first step. Second step, differentiate what is inside the bracket. Don't care about the power here already. Differentiate what is inside the bracket, and you get 2. So this one becomes 2x minus 1 to the power of 3. 2 times 4 times 3, 24. So far, do you know what I'm doing or not? Do you know what I'm doing?
Yes.
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 You understand the agreement between the two of the between us?
Yes, understand.
Differentiate the bracket, then differentiate inside the bracket. Other people
Mm.
cannot understand. Just between the two of us, I mean the group of us only, right? Now,
Okay.
okay. Now I'm going to differentiate this. Okay, I'm going to differentiate this. Now I ask you, first of all, is this a composite function? Does this need to use the chain rule? What is the condition for using the chain rule?
Have a bracket and a power raised
Correct.
R.
Okay, correct. Now this type of language, Li Ying, between us only, other people don't understand what we are talking about. Must have bracket, must have power. People don't understand, but never mind. We understand. We know what to do enough. You don't worry about this one or wow, dy, dx, du, dx, du, dx, dy, du. Okay, don't worry, right? So now the first step is what? Shelby, do you know what is the first step? Don't type, just talk. I want to differentiate this one. First step is what? Cannot hear.
Index number in front.
Yes, yes. Put the number in front. Put the number in front. So this index here, you put in front, 5. After you put in front, the 5 less by 1 already become 4. 5 less by 1. But this is the first step only. Second step, differentiate what is inside the bracket or inside the bracket. Do you know how to differentiate what is inside the bracket? This is 6x minus 1. Differentiate this is 6x. Differentiate this is 1. Yes. Question. Come. What's your question?
No, sir, no question.
No question. Okay. So you know how to differentiate this. Now this is correct already. But then you have to simplify, right? The differentiation is complete. You must know how to simplify. So to simplify, I gather all the numbers first. So I see got numbers or not? Yes. Only one number, 5. Right? 5. So I put the 5 in front. Then after all the numbers you have gathered, then the one with the higher power you put in front. The index is higher, you put in front. This 4 you put in front. Then 6x minus 1, the index is only 1. Then you put at the back there. Okay, so composite function, chain rule, 2 step. Differentiate the bracket, then differentiate inside. Okay, right. Wow. Okay. Do you know how to differentiate this one? You copy down the question, then we are going. The time is up already. We go for the second session. You copy down this question first, and also this one. Then you do on your own. See whether you can do this and this or not. You copy these questions, right? You try using the steps that I have told you. This question you copy, then this question you copy and see whether you know how to use differentiation using the chain rule. Very soon they're going to off already. 2 minutes left. Have you copied?
Yes, teacher.
Okay, you have copied, then try on your own first. Copy the 2 questions, then try on your own. I will give you the new link in a few minutes time.